Hello, this lesson is 6.1, day 1 of 6.1, and we're going to talk about right triangle trig. In geometry, you had 3 trigonometric ratios, and that was sine, cosine, tangent. And it's abbreviated, it looks sin, cos, tan, but we never say that. We still say sine, cosine, tangent. And it's in relationship to a particular angle in the triangle. And this one is talking about angle A. So sine, cosine, tangent is sine, the definition is opposite over hypotenuse. I'm just abbreviating. Cosine is adjacent over hypotenuse. And then tangent is opposite of over adjacent. And you're like, okay, so how does that relate? It relates to a right triangle. And for this right triangle, it's over here. We can see we're talking about angle A. So the relationship has to do with a triangle. So we can see that clearly this is the hypotenuse. It's the longest side opposite the right angle. This side, BC or X, is the it's the opposite side because it is across, it's opposite. Y, or side AC, this is the adjacent side because it's adjacent to angle A, which means next to. Okay, so how do you write that? So we write it as a ratio as a fraction. And so we can have sine of angle A, so opposite over hypotenuse over H, so that is X over Z. Cosine is adjacent over hypotenuse, that's Y over Z. And then tangent is opposite over adjacent, which is X over Y. Now, sometimes we write this abbreviation, and most people know it as SOHCAHTOA. And I will say to practice this, I write it on every homework assignment. SOHCAHTOA. SOHCAHTOA. Now that's for angle A. What about for angle B? Now when we do the trigonometric ratios, you can only use the acute angles, which would be A and B. So you would never find sine, cosine, tangent of angle C. So if you're doing angle B then, well, its opposite side is over here. So you have to change it. So now this is opposite. So you really have to know what angle you're talking about. And therefore, this now is adjacent. The hypotenuse stays the same. So the sine of B is still, this doesn't change though. So SOHCAHTOA does not change. It's still opposite over hypotenuse. But now it's Y over Z. So you can see it's changed from this one, but the denominator is the same. Cosine is adjacent, A over H, adjacent over hypotenuse. So now it's X over Z. And this TOA is opposite over adjacent, which is Y over X. So let's take a moment and compare the ratios from angle A to angle B. And it's really important that you keep this. Some people drop the angle, but don't, because then you're not sure which angle you're talking about. So we can see, let's look at the relationship between sine and cosine. So the denominators are the same, but this is xy here, and this is, x over z, and then this is x over z. So the sine and the cosine switched. Let's see if that's true for the other one. Yes, see? So they switched. What about the tangent? What is the relationship? Well, you can see x is on top of then z. Oh, I did that wrong. I know, you probably were yelling at me. Miss Mendoza, that's totally wrong. Sorry, couldn't hear you. My bad. Sorry, that is opposite over adjacent. It should be x over y. And then Okay, so now that I've fixed that, glad we went over this. So not to confuse you, you can see that x is in the numerator, y is in the denominator, and then here, this way, it's switched. So these two are reciprocals of each other. So there's this nice relationship happening between the two angles, the acute angles. So this is something that is taught in geometry. So in trigonometry, we're now going to add 3 more ratios. So there's actually 6 you need to know. So we still have our sine, cosine, tangent, but now we add 3 more. And the 3 that we're going to add is cosecant, secant, and cotangent. And their abbreviations, this is cosecant, this is secant, and cotangent. And they're written in a particular way. There's a reason why. And I would write them and suggest you write them in this order every time. So sine, cosine, tangent, cosecant, secant, cotangent. So for sine, we know it is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And this is for angle A. For cosecant of angle A, it is now hypotenuse over opposite. For secant is hypotenuse over adjacent. For cotangent, it is adjacent over opposite. So these 3 here are reciprocals of the original 3. So this is why I write it now, so that you know it goes this way. So if you can find sine, cosine, tangent, then you can find cosecant, secant, cotangent. Now please note the letters. Students get confused. The sine goes with the cosecant. Do you see they're opposites? The S and the C, they're not the same. They've switched now. And the cosine goes with this S. And then tangent, cotangent. All right, so I do like to label it. It's a good practice, especially when you're learning in trig. There's a lot to know. So the opposite, so this is A, my opposite's here. And not to be confused with the letters of the side itself. For problems that you'll be given, they'll be given numbers. And then over here, this is adjacent. So we've done these before, x over y, right? Opposite over hypotenuse, adjacent over hypotenuse. Oh my gosh, I did it again. So sorry, people. Okay. Adjacent over hypotenuse, and then tangent is y over, or x over z. Okay. Let me just double check. Yeah, looks good. So to do these, you're going to make a reciprocal. So this is z over x. So you're just taking these and I'm flipping it. Z over y, and then y over z. Y over x. Or you can look back. It's the same. Okay. Some people for this, as we do SOHCAHTOA, for the other 3, I've heard SHOSHACOW. You're like, what? I know, that's what I've heard, SHOSHACOW. I don't remember it. I don't, but just in case you hear it. I just remember SOHCAHTOA and remember the reciprocals. So let's practice. All right, so we're practicing the trig ratios. And we can see this is for z, and then this is for angle x. So if we're looking for angle z, I'm doing it in blue. This is my hypotenuse, opposite, adjacent. Okay, so my sine is opposite over hypotenuse. cosine is adjacent over hypotenuse. And then the tangent, I'm going to just write it underneath. It's a little squishy. There we go. And then cosecant, it's the reciprocal of sine. Write this over here. And then this is a reciprocal of cosine. And then cotangent is the reciprocal of tangent. Now for x, I'm going to mark it in a different color. It does help. I'm going to change this. This is now going to be my opposite. This is now going to be my adjacent. So my sine is opposite over hypotenuse. So it's E over G. My cosine is W over G. And the tangent is E over W. And for these, it's going to be the reciprocal of the sine cosine tangent. Right? Okay. Excellent. Just making sure I did these right. Okay. All right, now let's practice with numbers because that's really what we're going to be using. So if I look over here, and the triangle now has rotated a little bit. It's not in a different, it's now in a different position, which they will be. So, and you have to look at the angle. So I'm looking at C, right? So that's the one I'm going to start with. So now I'm over here. So let's label it. So still my hypotenuse, my opposite's over here, and then my adjacent's over here. Whoop. Okay, I'm missing a number. I don't have one. Okay, that means you have to find it. That's right. Now, because I know it's a right triangle, I can use the Pythagorean theorem. So I'm going to find this. I'm just going to call it x. So I have 8 squared plus x squared equals 10 squared. It's going to be 64. And this will happen. So if you're missing a side, you either use the Pythagorean theorem or one of the special right triangles shortcuts. All right, so that's going to give me 6. So please, if you're missing a side, yes, you have to find it. You can't just leave it blank. So now we go over to our sine of angle C. So it's 8 over 10. Cosine is 6 over 10. And then this is 8 over 6. All right. Do you have to simplify it? The answer is yes. So I'm going to do it after I find it. I'm going to now simplify it. So dividing by 2. There we go. And so now when I find cosecant, secant, cotangent, I'm going to use the simplified version. Now we're going to do the other angle, G. I'm going to circle that, going to cross that out. That now becomes the adjacent. Now this becomes the opposite. So this is going to be 6 over 10. This is going to be 8 over 10 and 6 over 8. And again, I'm going to simplify it, dividing by 2. And then for these, reciprocal. So how do we use the trigonometric ratio? So another way to do it is actually if you're given 1 and you have to find the other 5. So it says find the third side of a triangle using the given trigonometric ratio, and then write the 5 missing trig ratios for theta. Theta is in the first quadrant. So this is a Greek letter of the alphabet called theta, and we'll use it to represent an angle. So if we're in a quadrant, right, we're in the first quadrant, so we're here. And this is going to be theta. Now remember, sine is opposite over hypotenuse. So my opposite, if this is my theta, my opposite's here. So this is 5. This is going to be my hypotenuse is 13. So we have to find the adjacent side here. And guess what we're going to use? That's right, we're going to use the Pythagorean theorem. So I'm just going to call it x. Now, after a while, sometimes I use the numbers over and over again. So you may get used to certain numbers. Some of you, if you remember in geometry, 3, 4, 5 is a common triplet that they use. What is this? 144. This is 12. All right. So we already have sine. So we need to find cosine of theta, tangent of theta, and then remember cosecant goes first, secant, and then cotangent. All right, so this is my opposite, this is my adjacent, and this is my hypotenuse, SOHCAHTOA. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then I'm going to do the bottom 3, and I'm going to use the reciprocal. Okay. There you are. Now for our next one, okay, this is secant. So now you have to remember, what is secant? So secant is hypotenuse over adjacent. So I'm going to draw a triangle again, first quadrant. So my hypotenuse now is 7, and my adjacent is 4. Now, looking at this, remember this is going to be c, so we have to find this side. So it's 4 squared plus x squared equals 7 squared. Okay, so it is going to be the square root of 33. Can't simplify, you're just going to have to use that, square root of 33. We can do that. So sine, theta, cosine, tangent, cosecant. Secant we've already done. I'm just going to write it there just because it may confuse me if I don't. All right, so opposite, adjacent, hypotenuse. So square root of 33 over 7. 4 over 7. Opposite over adjacent. Okay, cosecant. Now we're flipping here. 7 over root 33. Now, when we do that, can I have a square root in the bottom? No. Do you remember I have to multiply the square root of 33 over the square root of 33? Yes, I wrote it very tiny. So it turns into 7 root 33 over 33. So you can see why we did Pythagorean theorem earlier and practiced that. All these skills are going to come into play. So this one we're flipping as well. Again, square roots in the bottom. So we're going to multiply by the square root of 33. So that's going to be 4 root 33 over 33. This is 7. Here's another problem. It's where you have a point on the terminal end of the angle and a standard position is given. All right. And then find the exact value of each 6 trigonometric functions. So when we talk about standard position, in here, when we did it, when I drew that triangle, you can see that I drew it from the center, the origin, out. And that the legs, one is here on the x-axis, and then the other one's out. And that's will happen every time. Doesn't matter what quadrant you're in. So let's draw it from here. So if I'm looking at -5, 4, that point is in the second quadrant. So standard position, you're starting here with the origin. You're going to have one leg here on the x-axis, and that's going to be -5. So my point here is -5, 4, right? So this side here is -5. That's your x value. Then up here is 4. So now we have to find the hypotenuse. And for these problems, it's going to be standard that when you do this, given a point, it'll be the legs. So I'm looking for here the hypotenuse, and that's going to be our C. Notice that I put a parentheses around the negative, because when you square it, it's going to be a positive. Okay, 41. Okay, and I cannot simplify that. So it's just going to be the square root of 41. All right, so now that I have my triangle set up, and I'm going to label the sides, I can find sine of theta, cosine of theta. You're like, Ms. Mendoza, that's a lot to write. But it's quick. And it helps you practice to get used to them. All right, so I have opposite over hypotenuse, square root of 41. Don't like the square root of 41, going to multiply that. So it's 4 root 41 over 41. Remember, the square root of 41 times square root of 41 is some number, but that'll undo, and it's just 41 without the root. All right, so the adjacent is square root of 41. Same thing, and after a while, hopefully you'll get used to, and you'll see my shortcut, that I can go straight to here. For my tangent is -4 over 5. Yes, and the signs are important. So here, I'm going to do the reciprocal of this one, the original. And the reason why I'm going to do that is because when you flip it, the 4 will be on the bottom. And then there's nothing to multiply. If you try to do a reciprocal of here, it gets very complicated. Same thing for this one. You negative square root of 41 over 5. Tangent is -5 over 4. Okay. And there we are. So here are the 6 trigonometric ratios. Remember sine, cosine, tangent, SOHCAHTOA. And then cosecant, secant, cotangent, the reciprocals of these. So, ka, toa. All right, this is your practice on your own. Please read the directions and make sure you know which problem it is like, so you can look back at your notes. If it's like this example or these. And then after you're done with that, don't forget to answer the EQ. Thank you for watching. Bye.